Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are on the topic trigonometry. In the previous video, we applied the trigonometric ratios and the Pythagoras theorem to solve a question. In this video and the subsequent ones, we are going to apply the trigonometric ratios and the Pythagoras theorem to solve practical problems. So when you have a practical problem, how do you use trigonometry to solve it? The first thing you need to do is to read the statement carefully. So you read the statement or the question that has been given to you very carefully. Then you draw an appropriate diagram for the statement or the question if a diagram was not given to you. So if the question gives you a diagram, fair enough. But if it doesn't, you have to draw an appropriate diagram. Then you use letters to represent the unknowns in the diagram. So what you want to find, maybe an angle or a given length, you use letters to represent it. Then you find the unknowns by using the Pythagoras theorem and the trigonometric ratios. So you apply the Pythagoras theorem and the trigonometric ratios to find the unknowns in the diagram. Let's pick a question and see how to do this. The question for this video is: a ladder leans against a vertical wall. If the foot of the ladder is 16 meters away from the wall and the height of the wall is 20 meters, find I, the vertical angle between the wall and the ladder, II, the length of the ladder. So in this question, a diagram was not given to us, so we have to draw the diagram ourselves. So we have the question here once again. It says that a ladder leans against a wall. So that's what we are going to do. We have this as our ground level, then we have this as the wall. Definitely the wall will be on the ground, so the wall is on the ground. Now the question is saying that a ladder leans against the wall. So there's this ladder that leans against this wall. Okay. If the foot of the ladder is 16 meters away from the wall, so if the ladder leans against the wall, this is the foot of the ladder. The foot of the ladder is the part of the ladder that is on the ground. So the part of the ladder that is on the ground is called the foot of the ladder. The question says that the foot of the ladder is 16 meters away from the wall. So from the foot of the ladder to the wall is 16 meters. So it means that from this point here to this point is 16 meters. And the height of the wall is 20 meters. So the height of this wall is 20 meters. So this wall is also 20 meters high. Correct your answer to three significant figures. I, the vertical angle between the wall and the ladder. The vertical angle between the wall and the ladder. Now you see, because the ladder is leaning against the wall, there will be an angle created between the ladder and the wall, which is this angle that we have here. So this particular angle. This angle is what we are talking about. The question is saying that we should find it. We should find the angle between the wall and the ladder, so this angle. And we should also find the length of the ladder. From here you can see that this is the ladder, so you should find the length of this ladder. Now you can see from here that the wall is on the ground. Looking at how the wall is on the ground, this side is a right angle or the 90 degrees angle. So we can form a right angled triangle from this diagram. So we form this simple right angled triangle. This is the ladder, this is the ground level, and this is the wall. I'll call this point here point L. I'll call this point here point W. Then I'll call this point here point G. From the diagram here, you can see that between W and G is 20 meters. Between L and G is 16 meters. And this is the right angle, as we can see. So the question is saying that we should find the vertical angle between the wall and the ladder. We have seen that is this angle here. So from our right angle triangle is going to be this angle. This is what we are looking for. It also said that we should find the length of the ladder. The length of the ladder from our drawing here, or from our right angle triangle here, would be LW. So we find LW. Okay, so let's go ahead and apply the Pythagoras theorem and the trigonometric ratios to find what we want. The question says that we should find the angle between the ladder and the wall. As you saw, if we let that angle to be equal to theta, on our diagram, you see that theta is this angle because that is the angle between the ladder and the wall. So we are looking for theta. This is a right angle triangle. 16 meters is opposite to theta and 20 meters is adjacent to theta. So we have opposite and we have adjacent. So we are going to use tan to solve for theta. So we can say that from this diagram, tan theta is equal to 16 meters divided by 20. So the meters and the meters will cancel. So we have tan theta is equal to 16 divided by 20. To find theta, you are going to find tan inverse of 16 divided by 20. So theta is equal to tan inverse of 16 divided by 20. We have learned how to find tan inverse on your calculator. So theta is equal to 38.7 degrees. So you press shift, then you press tan, and you enter 16 divided by 20. That will give you tan inverse of 16 divided by 20, which is 38.7 degrees. The question said we should correct our answer to 3 significant figures. So if you find this on your calculator and you correct your answer to 3 significant figures, you are going to have 38.7 degrees. If you watch the video on approximations, I explained how to correct your answer to a given significant figure. So it means that the angle between the ladder and the wall is 38.7 degrees. The question also said we should find the length of the ladder. From our diagram here, the length of the ladder is the length LW. So we have this as our right angled triangle. We know LG, we know GW or WG, and we want LW. Once again, this is a right angled triangle, so we can apply the Pythagoras theorem. If you apply the Pythagoras theorem on this right angled triangle, you will see that LW squared, which is the hypotenuse squared, is equal to LG squared plus GW squared. We want to find LW. We know LG, we know GW, so we can find it. So LW squared is equal to 16 squared plus 20 squared. You simplify this and you are going to get LW squared is equal to 656. You take square root of both sides and LW is equal to 25.6 meters. So if you find square root of 656 and you correct your answer to 3 significant figures, you have 25.6 meters. Once again, if you want to learn how to correct your answer to a given significant figures, watch the video on approximations. I explained how to do that and how to use your calculator to do that also. So the length of the ladder is 25.6 meters. So we can say that the ladder is 25.6 meters long. So applying the Pythagoras theorem and the trigonometric ratios, we have been able to solve this question. Thank you for watching this video. I hope you enjoyed it. If you did, don't forget to subscribe to this channel if you haven't done that already. In the next video, we are going to apply the Pythagoras theorem and the trigonometric ratios to solve another practical problem. Bye-bye.